Hi, this is YuZhang, and this is the second part of the project demonstration, which is to show the proof of concept for my final project. Firstly, about all the mathematics, I will have shown how I did the derivation for the force calculation and geometrical description of the system in the previous lecture, in the previous presentation. So here, what I want to show is some simple validation of the model and the collision detection I designed for the model. So firstly, since one of the main part for the model is to define the motion of the flexible beam, and here I'm using this calculation shown here to compare the analytical solution of elastic beam deflection versus the numerical simulation result. The test cases are set up as this. I have the length, some basic geometries of the beam and the density mechanical properties, along with the force applied to the beam defined in the table. And as I show here, the displacement difference between the analytical solution and the numerical simulation are fairly close. The error is within 0.15%, especially when I increase the number of elements for beam, I can see increasing of the performance of the uh, um, of the accuracy for the calculation, although it's not that significant because for beam deflection calculation, we do not need a very high order of polynomial to represent the deflection properly. So that's why you can see with two elements, I already have a very high accuracy on the endpoint. But for this project, I actually need a better representation of the detailed deflection configuration of the beam under some complex postures. So possibly I might have a very complex geometry gesture of the VV configuration of the beam. That means two elements will not really be a good choice. I might need to use more elements. For that, I need to do some experiments with the model. But again, that will be given as one of the input parameters of the system. So user can choose how many elements they want to use to formulate the flexible object. Next, because the model is overall going to be a dynamic model, I want to check the dynamic motion is is valid and accurate. So the way I do that is to extract the data from a paper and doing the simulation with the same configuration is going to be a dynamic motion, rotational motion of the beam with flexible bending involved in the system. And so as you can see, these are the comparison between the literature data with the simulation data. So the two curves are very close with respect to each other, showing high accuracy of the numerical simulation. So this is a different figure showing the dynamic simulation have a high agreement with the literature data. The next part I want to emphasize is the collision detection mechanism introduced to the system, because there will be many flexible objects involved and there will be collision happen between the objects. So in order to have a meaningful physical representation of the system, I need them to be able to detect the overlap and have some corresponding force to push them away, such that you don't see penetration of the object during simulation. That will be highly invalid, and that will be an invalid situation. So after I implemented the collision, this is how a simple demonstration of how the collision will work. So in the first configuration, I have two flexible objects standing up, and then I have a horizontal force pushed on the red beam. And as it bends, it will start to collide with blue beam and start to push it away. And this, you can see, because I have collision detection mechanism between the two beams, the red beam is not able to penetrate through the blue. Instead, they move collaboratively and eventually reaching a stable condition, which is the last figure. And pretty much that's what the collision detection mechanism I want the system to have, which is to prevent the invalid penetration between the physical objects. So this is the proof of concept for the second main component of the project. So in the future, there will be implementation of beam particle collision as well. And that will, but the basic concept is pretty much the same as this one. So that's my demonstration of the proof of concept for the project. Thank you very much.